Ever wondered how big the universe really is? It's a question that has fascinated and bewildered humanity for thousands of years, and still really hard to fathom. But we're going to try to give you a sense of its size just by discussing the Milky Way, our home galaxy. The Milky Way is a dazzling spiral of stars, dust, and gas, a celestial carousel spinning in the grand cosmic carnival. In our quest to understand the Milky Way, let's first step back and marvel at its basic structure. Picture in your mind a cosmic whirlpool, a grand spiral galaxy with long sweeping arms that stretch out from a dense central bulge. This bulge is the heart of the Milky Way, a bustling hub of starry activity. Stretching out from this central hub are the spiral arms, vast pinwheels of stars, gas, and dust. These arms are like the Milky Way suburbs, home to countless stars and the cradle of new star formation. And then there's the halo, an almost ghostly sphere that surrounds the galaxy. The halo is like the Milky Way's countryside, a quieter region dotted with old dim stars and globular clusters, spherical gatherings of stars that orbit the galaxy's center. Now let's talk numbers. The Milky Way is home to an estimated 100 to 400 billion stars. That's right, billion with a B. If you were to try to count aloud every single star in our galaxy, it would take you around 8,000 years, and that's without taking any breaks for sleep, food, or anything else. Question: what star is so bright that you can see it in the daytime? Do you give up? It's the sun, silly. So when we say a billion stars, we are referring to a billion objects resembling our sun. Every time you hear the word star, just think another sun. But the Milky Way isn't just about its many suns. It's also a galaxy teeming with planets, comets, and asteroids orbiting those suns, and all sorts of other celestial bodies, just randomly orbiting the Milky Way system. Now that we've set the stage, let's dive into some lesser-known facts about our home galaxy. Did you know our Milky Way is not as flat as it appears to be? It's a common misconception born from simplistic depictions in popular culture. Our home galaxy is far more complex and intriguing than just a mere flat disk. Imagine, if you will, a cosmic pancake. That's how most of us picture the Milky Way. But this pancake is not evenly cooked. At the edges, it measures about 1,000 light-years in thickness. But as we move towards the bustling center, it thickens to a robust 16,000 light-years. That's a whole lot of cosmic batter. Our Milky Way structure is not just about thickness, though. There's a fascinating twist to its tail. It's warped. Yes, warped, like a vinyl record left out in the sun. This warp means that the outer regions of the Milky Way are twisted, bending away from the galactic plane. It's not a random bend, however. The warp follows a precession motion, much like a spinning top. So why is our galaxy warped? Astronomers believe it could be due to the rotational force of the Milky Way's massive inner disk. Alternatively, it may be due to the gravitational pull of nearby galaxies or even dark matter. The truth? We're still figuring that out. Yet this uncertainty doesn't make our galaxy any less mesmerizing. In reality, the Milky Way is a grand cosmic ballet, with hundreds of billions of stars pirouetting in a beautifully choreographed dance. Each star, including our sun, is a part of this performance, tracing a path around the galactic center. And we, on our tiny blue dot, are privileged audience members, watching the spectacle unfold across the eons. Indeed, our home galaxy is not just a flat disk, but a beautifully warped spiral of stars. It's an ever-evolving, dynamic entity, full of mysteries waiting to be unraveled. As we delve deeper into the cosmos, who knows what other surprises the Milky Way might reveal. Ever feel like your world is moving too fast? Well, it is. As a matter of fact, our entire galaxy is hurtling through space at an incredible speed. Welcome to the third act of our cosmic journey, where we're going to delve into the mind-blowing pace at which our Milky Way galaxy is cruising through the universe. Strap in, because it's going to be a wild ride. Picture this. Our galaxy, with its roughly 100 billion stars, including our own sun, is zipping through space at an astonishing speed of approximately 600 kilometers per second. That's right, 600 kilometers every single second. To put that into perspective, that's over 2 million kilometers per hour. At this speed, you could travel from Earth to the moon in less than a minute. And since we're ultimately trying to paint a mental picture describing the size of the universe, here's a question. How much distance has the Milky Way covered just in the Earth's 4.5 billion years? Answer, well, it doesn't matter, because that distance wouldn't even be a rounding error in comparison to the size of the universe. And you'd probably need an entire sheet of paper to figure out how many miles that would be in a car. So, what's propelling our galaxy at such breakneck speeds? The answer lies in the colossal gravitational forces at play in the universe. Our Milky Way, along with dozens of other galaxies, is part of a bigger cosmic structure known as the local group. This group, in turn, is being drawn towards an even larger entity known as the Virgo supercluster. It's a cosmic dance on a scale that's hard to comprehend. But how does this affect the galaxy itself? Well, despite its speed, the size of the Milky Way and the immense distances between galaxies mean that from our perspective, everything seems relatively locked in place. The stars we see at night aren't noticeably shifting their positions because of this unified galactic movement. It's a bit like being on an airplane at cruising altitude. Even though you're moving incredibly fast, it doesn't feel like it. So next time you feel everything is moving too fast, remember our entire galaxy is on a cosmic joyride. We're all part of this breathtaking journey, hurtling through the cosmos at a speed beyond imagination. Yet here we are, able to ponder our place in the universe amidst this incredible motion. So, how big is the universe? To put it in perspective, let's sum up what we've learned about the size of the Milky Way galaxy. This grand cosmic city we call home stretches across an incredible 100 to 200,000 light-years in diameter. That literally means what it says. If you were able to travel at the speed of light, it would still take you 100,000 years to go from one side to the other. Not impressed? Well, let's give you even more numbers. Light travels at 1.08 billion kilometers per hour. That's almost 300 million meters per second, or more than 670 million miles per hour. Traveling at that speed, you would be able to go completely around the Earth 7.5 times every second. But that speed couldn't get you from one side to the other of the Milky Way in a human lifetime. Galaxies are big, really big. So how can we use the Milky Way, a decent-sized galaxy, but nowhere near the largest, to put the size of the universe into perspective? Well, here it is. If you were to take a quarter and hold it at arm's length to cover the sky behind it, it wouldn't cover much sky at all. Just imagine how many times you would have to move it around to cover a complete sphere around yourself. Well, there is a telescope out in space called the JWST that has taken a deep field picture of the amount of space your quarter can cover, and hopefully from watching this video, you now have a sense of the size of a galaxy. Let's take all this into consideration and look at this picture taken by that telescope. This picture is a typical representation of what can be found out in space, behind the very small amount of sky that your quarter can cover. A majority of the objects pictured here are galaxies, thousands of them. Looks like they are everywhere. But in reality, if you were on a planet in any one of them, the distance to the next one is so great that another entire galaxy would only look to be just another star in the sky. And don't forget, every time you reposition your quarter, you are just as likely to see the same amount of objects behind its new position. Ponder that for a second. Thanks for watching. Check back often as new videos are added as completed, or subscribe to receive notifications when new content is added.